How do we find the equation of an inverse if we're given the equation of a function? Well, here's some steps to guide you. If necessary, replace f of x with y. Then interchange x and y, or you can just say switch who is x and who is y. Then solve for y, and then finally replace y with f inverse of x, because when you solve for y, it will be in terms of x. So let's jump right into an example following these guidelines. The given function f is 1 to 1. F of x equals x cubed plus 1. Let's find its inverse. So the first step is, let's write y equals x cubed plus 1. Then we want to switch who is y and who is x. So it's going to say x equals y cubed plus 1. Now solving for y means we need to isolate y first. So we're going to subtract 1 from both sides of the equation. We'll have x minus 1 equals y cubed. And now finally, to solve for y, we take the cubed root of both sides, so we would have the cubed root of x minus 1. And the last step will be to replace y with f inverse of x. So f inverse of x will be the cubed root of x minus 1. How do we verify this? Well, remember, we need to take f composed with f inverse, and then also f inverse composed with f, and we should get back x. So let's do this work. So f of f inverse of x is, we will take f of the cubed root of x minus 1, and that just means wherever in f we see an x, we're going to replace it with the cubed root of x minus 1. So we're going to get the cubed root of x minus 1 cubed plus 1. Well, that will be x minus 1 plus 1 equals x. So that's good in that direction. Now let's go the opposite direction. F inverse composed with f. So that'll be f inverse of f of x. So that'll be f inverse of x cubed plus 1, which will be the cubed root of x cubed plus 1 minus 1. So that'll be the cubed root of x cubed, which is x. So we verified algebraically that f and the f inverse we found are in fact inverses of each other. Now let's graph them. So let's pick some easy points on x cubed, and then we'll do x cubed plus 1. We'll do this through our transformations. Remember, our anchor points or key points would be -1, -1, 0, 0, and 1, 1. And now we're just adding 1 to all of the y values. So we'll have -1, 0, 0, 1, and 1, 2. That would be x cubed plus 1. For our parent function, the cubed root of x, we'll also take our key points, which happen to be the same, -1, -1, 0, 0, and 1, 1. And now we're going to subtract 1, or excuse me, it's x minus 1, so that means we're going to add 1 to every x value, because it's a shift right 1 unit. So we'll have 0, -1, 1, 0, and 2, 1. So if we look at these on the same graph here to the right, remember we'll have this identity y equals x is our line of symmetry. So if we just graph these points, let's see, we're going to have, this is going to be f of x, and we know this is a snake curve, an S curve. This is f of x. And then for f inverse, which is the cubed root of x minus 1, we're going to have 0, negative 1, 1, 0, and then 2, 1. And this is more of a flatter S curve. So my points keep going away here. There it is, something like this. And I probably should have changed colors, but we can see that these do look like reflections over the line y equals f. This is f inverse of x, which is the cubed root of x minus 1, and f of x was x cubed plus 1.